Hello, in this video we're going to be using the Karnaugh Map to minimize some Boolean expressions. So we're going to see more examples in this video of the K-map. But before we get to examples, let's look at the steps in using K-map. How do we find the minimum sum of products form from the K-map? That's what we're going to be learning. So we must use every marked square of the map, and we want to include the largest combination of marked squares possible, since doing so will reduce the expression as much as possible. However, we cannot begin by simply looking for the largest blocks or marked squares on the map. So what we do first, the steps are as follows. You set up the grid, and as I said in my previous video, you set up the grid correctly. It's very important. Using correct labeling for the number of Boolean variables. And again, K-map is used when you have up to 4 variables, x1 to x4. And to insert ones in the table form in the terms in canonical sum of products expression, form terms for many isolated marked squares, combine squares uniquely into 2 square blocks if possible, or 4 or 8 square blocks. Combine any remaining unused marked squares into blocks as efficiently as possible. Here is an example. So this one, for example, here, if you have a truth table, it will be x1 not, x2 not, x3, and so on. So this example here, in this example here, I see that we have more than one method. So what we could do in red, so I will mark these two together, and maybe this together. So if I do this, what we have? So we look up, I see that x2 varies from x2 not to x2. So x2 varies, we keep x1, and we look horizontally, we take x3. So we have x1 not, and then x3. That's from the square there. This is from this combination of these two here. And then if I go to here, if I look horizontally, x3 varies, so we're going to cancel it. And when we look up, what's left is x1 not, x2. And then this combination here, you look up, what I see varies is x2, so we will cancel. So I'll keep x1 and x3 not. So this is one method. This is one way. I did it in different color in red. Another way, we could combine this one here with this one, and then combine these two here, and then combine these two here. So if we do this, again, this combination, that will lead me to x1 not, x3. And then the one on the side, we could have x2, x3 not. And then this combined two ones here. If you look up, I see that x2 varies, so I'll keep x1, x3 not. So here we have more than one combination of this sum of products. Similarly, we'll try the next example. So you could stop the video and try it yourself and then see if we match. And again, make sure you for largest group of ones adjacent to each other. So by looking at this, I see that I could combine first this group as 4 and then this other group here. So this other group here, if I look up, everything varies, so they all cancel. What's left is just x3. And if I look at this group of 4 here on the sides, you look up, I see that x1 varies, so we'll cancel. And horizontally, x3 also varies, so we will cancel. So what we have left with is x2. So the whole thing gets simplified to x3 plus x2, or you could say x2 plus x3. So the next example, again, think of the largest group you could think of. You could stop the video, try it. So I see that I could have these 4 here, and if I write down what is those 4s, it's gonna be look up or look vertically. I see that x1 varies, so x2 not stays. And if I look horizontally, I see that x3 varies and x4 not stays. Then my next largest group will be this one here. And if I look everything, so if we look horizontally, x3 and x4 varies, so they get cancelled. And if you look vertically, what I have left is x1, x2 not. And then I have these two, and that's gonna give me x1 not, because x2 varies. And if I look horizontally, I have x3, x4 not. And the next one will be this one here. And again, look up, you see that x2 varies, so it gets cancelled, and what's left is x1. And horizontally left with x3 not and x4 not. And this is one way of finding the answer. Here is one more example. So we can have groups of 3, but what we could do is this. We could group this 2, and that's this way. That will give me x2 not, x3, x4 not. And then I will have this group here, or maybe not. And then I see that I could group this one here with this one here. And this way I have x1, x2 not, nothing changed there, but horizontally we went from x3 to x3 not, so all what's left is x4. And then I could choose this group together, and vertically x2 is gone, but x1 not stays, and horizontally I have x3, x4 not. So this is one way. The other way is as follows. Let me erase everything. So what we could do is I could group these two together, and this way I have x1, x2 not, and then x3. And I could group these two together, and I will have x1 not, x3, x4 not. And then this last one can be grouped with this one here. And this way I could have x1, x2 not, x4. So we have more than one method of grouping the ones. So in this example here, where we have the truth table. So what we need to do first is write down the table correctly. So I have 3 inputs. That means I will have 8 squares. So as I said, x1, x2 goes here and x3 here. So you could have x3, x3 not. But right here, if you remember, we said 1, 1, 1, 0, 0, 0, 0, 1. Meaning x1, x2, x1, x2 not, x1 not, x2 not, x1 not, and x2. Then we think of the ones. We have to fill in this table. This one here is represented by x1, x2, x3, which is right here. And the next one here is represented by x1, x2, but x3 not, which is right here. And this third one here is represented by x1 not, x2. So x1 not, x2, which is right here. Or you could think of 0, 1, 0. So 0, 1, 0, which is right here. I'm sorry, which is 0, 1, 1. So here is 0, 1, 1, which is x3, 1, which is right here. So how do we group this? So first thing, I see that I could group these two together, and that will lead me to, if you look up, x1 varies from 1 to 0, or from x1 to x1 not. So what's left is x2 and then x3. And the next one, I could group these two together, and this gives me x1, x2, because x3 and x3 not cancel out. If you look horizontally, they cancel out. And this is the minimal sum of product form for this truth table. Let's see another example here. So what I have is up to 4. So what I'm going to do first, I have to draw the table. So the table must be correct. So as I said, 11100001. You could just write only 11100001, but I have to change everything here as 0011 1101 0001 and so on. And then we're gonna copy it down. So you have 0011. So you look for where is 0011. So I have this one here. Similarly, the next one I have 1101. So here is 1101. That means I have this one here for the next one. 1101. And so on. So you finish the table by grouping the largest groups you could find. So right here, I see that I could group this 4 with this 4. And if I do that, that will give me, as you look up, I see I see variation in x2. What's left is x1 naught. And if you look horizontally, what varies is x3. So it's gone, and what's left is x4. And the next group of 2 can be these 2 here. You look up, what varies is x1, goes from 1 to 0. What's left is x2 naught. And horizontally we have x3, x4 naught. And then I have this one here, can be connected with this. And this way we have, look up, I see x1 is gone, what's left is x2, and then horizontally x3 naught, x4 stays. And this is the answer. Sometimes you, instead of the truth table, you could have a network with 3 variables as follows. So as we see the 3 variables, you could see that what I have here is x1, x2, x3, x1, x2 naught, x3, and so on. Let me write them down. So as you see here, we have input of 3. So we have a table with 8 square. 11100001. So you have x3 and x3 naught here. And now we're gonna just find out, write down all these inputs here. And let's see. So as you could see here, we could group this one on the side. That will give me x2, because x1 is gone, and x3, plus to this middle one, x1, x2 naught, and then the last one, x1 naught, x2. So this is one method. I will erase every group and then do it differently. So if I group this, we get x1, x2 naught, because x3 is gone. Similarly, x1 naught, x2, and then this one here can be grouped with this. And then what varies is x2 and x1 last, and then x3. And this is what's last is x1 and x3. And again, it says draw the network for both examples. So let's see here. Let's call this one the minimum sum of product example 1. And I'm gonna draw the diagram here. So again, we need x1, x2, x3. So here is the network for this first example. And the next example, I will